Okay, so what I'm going to do is go over something we did last week. And so I'm going to take us over to some paper. So this was the exact problem. Just confirm if it's not. Then,
That's it.
yeah, this is what we had to do. And so you have to divide by 65. Now, this is a little bit trickier because 65 is right in the middle. And so when you round it, I was suggesting people round just to make it easier, but 65 does not go into 17. That's a fact. In fact, what it'll do is it'll go into 177. And the question is how many times? And so it might be a little tricky. So what I was suggesting people do is do a little rounding so that they get an approximate answer at the very beginning. This may or
Okay.
may not be correct. So 65, I'm going to call it 70. And this is my own thing. And 177, I'm going to call 180. The only reason I'm doing this is so that I don't spend a million hours trying to guess what's the exact right answer, because this cuts it down to size, you see?
Okay.
So 7 into 18 would go twice. So I'm going to put a 2 here. Now you notice I'm working with a pen, so if I mess up, I can't erase it. But 2, so now the next step, of course, is to multiply and see if we have it. 2 times 5 is 10, carry a 1. 2 times 6 is 12, and 1 is 13. So we know it's right. The next step is subtract. So 7 take away 0 is 7, and 7 take away 3 is 4. If this number is smaller than the divisor, 65, we did it right over here. And so
Okay.
now the next step is just to bring down. So again, I have to divide 65 into this. And so again, just so that I make a decent guess at the start, I'm going to call this is actually rounded, so I'm going to call it 470. But I did that so that I could see, well, 7 into 47. So again, 7 times 6 is 42. 6 is a possibility. 7 times 7 is 49. I'm going to think 6 might be our best shot, but who knows? This works most of the time, but not every last time. So let's try it again. 6 times 5 is 30. Carry a 3. 6 times 6 is 36. And 3 is 39. I don't think I think we're going to have to adjust this. So this would be 0. But 17 take away 9 is 8. Well, I think it was good we did this because this is an example of we guessed wrong.
Okay. I think that's what was happening to me.
Absolutely. So this was perfect to show this because this is a clear indication that we didn't guess right. This is too big.
I see.
So what we have to do is to make this right, we had to go to the next number, which is 7.
Okay.
Now I'm going to rewrite it because it's a pure mess here. So 17, 7, 10. The first number was correct, and I'm going to put the numbers in that we already have. And if you have, so this is where it was still good. We brought this down, but when, oh, that was a mistake here.
Right. I was going to ask about that because the
Yeah,
one
I
didn't
brought
come
that
down.
down.
Okay.
But it didn't matter in the scheme of things. When we tried 6, it was too small because we had too much remainder. So I'm going to try 7 this time. Let's see how this works. 7 times 5 is 35. Carry a 3. 7 times 6 is 42. 42 and 3 is 45. Now, when I go to subtract this, see, this is smaller than that. And there's going to be a borrow here. So 11 take away 5 is 6. And when we borrowed, 6 take away 5 is 1. Do you see? And this is 0 here. So
Okay.
16 is smaller than 65.
Right.
This was the correct choice. And so it won't work every time, but within one, it was just slightly off and we fixed it.
Right.
Now, we'll try to bring down the correct number. So finally, it's 65 into 160. And so I don't know if you can see that 2 would have been the right choice. It's 7 into 16.
Okay.
So it works. It works most of the time. And if I was guessing 90% of the time, but not every time. So I'm going to go with a 2 here. 2 times this was 130 because we already did it. Right? We did it over here.
Right.
And so then when we subtract, it's 30. Well, do we like 30? We love 30 because it's smaller than this, which means all of this is correct. So
Okay.
now you have the answer 272, remainder 30.
Gotcha. Okay.
Okay, so you see
Alright.
how, none of this is perfect, but honestly, some people spin their wheels so long because they can't, they're dividing the big numbers. And so when we actually, did a little of this, the rounding, we got there quicker. And so I think that's it. How's that? Does that work for you now?
Yeah, definitely. That clarified. Thank you.
Okay. Does anybody else have anything else from the previous work up to 1.6 before I start 1.7?
I
Go
do have. Hello.
Go ahead.
Yeah. Can I share my screen because it's kind of a little bit hard to explain?
Let's see. Get out of this. Let me. Go ahead and try to share your screen. So the only way this will work is you have to find the share screen button, which in my case is green. I'm sure it's green. And
Yeah,
then
I
you
got
have to hit that first. And sometimes somebody's computer will block this. Oh, there you go. Perfect. Show it to me now.
It's this one.
Okay, so this is chapter 2.
Yeah.
I haven't gone over chapter 2. So let me go over that first. And then
Okay.
maybe we can come back. Okay?
Okay, gotcha.
Somebody
Thank
else
you.
has asked about a chapter. So could you stop share? Okay. So what I want to do, this is great. So what I want to do is, I want to go back to this. And I want to start 1.7. So 1.7 is order of operation. And I have a couple of problems for us to look at. And so I want to know what you think the correct answer is to this one, this first one. Anybody have an answer they think is correct?
It would be 3, right?
Great. Okay, anybody else have a different answer?
I think 7.
What?
I
7?
think 7.
Now, this is really important. Can this little problem have 2 different answers, completely different? What do you say to that? This is a no. If in mathematics, we keep having multiple answers for the same problem, we will never get anywhere. Does that make sense to you? We have to have a clear winner to this problem. And the only way to have a clear winner is have a list of what gets done first, and everybody agrees to do it. This list is called order of operations. Now, the operations, strange word, are basically add, subtract, multiply, divide, things like that. What do you do first? What's more important? And then everybody has the same exact answer. This is critical. And I suppose this is why they want you to work on this, 1.7 until you get perfected, because we don't want to make any more mistakes about this. And so sometimes when I ask people about problems, they give me 4 or 5 answers. Well, they can't all be right. And so we have to agree to what's important. So that we will resolve this in a minute. I want to see what kind of problems, what do you think the answer is to the second question? And I'm looking for multiple answers here because I'm trying to make the point that we've got to get organized here.
2.
2,
I would think 8.
8. Anybody else? I'll take any answer you have. Okay, those are the 2 obvious ones.
3,
Yeah. Anybody else? Anything else?
3.
Okay.
No,
You don't like it?
4.
Okay, we threw out 3. Okay, so here's the deal. What if I had a problem like, let me write this down. What if I had a problem like this? 2 times 3 plus 4. What do you think would be done first?
Parentheses.
Parentheses is the all-time winner.
Yep.
And so when there's parentheses, you do that first, if you can. And so 3 plus 4 is 7. Somebody needs to maybe turn their mic off. Can everybody do that? Turn their mic off. That'll get rid of the static. And this is 2. And this is a time symbol. And so now it's 2 times 7, then it would be 14. Okay? So parentheses is the first one. Here's the list, order of operations. Number 1, parentheses. Okay? And it also has to do with fraction lines. For instance, if you had 3 plus 9 divided by 2, you would actually figure out the top part first, which would be 12 divided by 2, and then you would go like that. So parentheses and fraction lines are first, but I'm going to call it parentheses. The second one that's in our list is exponents. Now, let's just take a look at exponents. If I had, for instance, if I had, let's do some exponents. 2 times 2 times 2. What's the other way to write that? 2 to what power?
2 squared.
Well, 2 to, give me a number. 2 to what power?
3.
3, okay? 5 times 5 is 5 to what power?
Second.
Second. So these, raising it to the second power and raising it to the third power are used a lot. And so they've given them nicknames. So instead of saying 2 to the second power, which is like a long thing, they also say, or 5 to the second power, they would say 5 squared. Okay? And because this one is used so often, 2 to the third power, they might say 2, do you know what it is? Cubed. This is coming out of geometry. When you have a square, you multiply the two sides. If this was 5, this would be 5, that would be 5 squared. But when you go to the third power, what happens? What's the visual? It's a cube. And so when you raise to the third power, you can always say 2 to the third power. You can say that. But people tend to say the short version, which is 2 cubed. This one here, 5 to the second power. Again, you could say 5 to the second power. Nobody's going to stop you. But a lot of people start to say 5 squared. This is okay? So we get used to the nicknames of this. So exponents. And so exponents are second. Now, the next part had to do with one of the problems I gave you. It had to do with this one. This is divide. This is multiply. Many people think multiply is much better, much more important than divide. That is not true. The two are equal. And so if you see multiply and divide back to back like these are, you go left to right. And so what you would have to do is this first. So 24 divided by 6 is 4. 4 times 2 is 8. This is the answer. So although I made it so that you were tempted to do this first, that was not the correct step. The correct step, because divide and multiply are equal in priority, you go left to right. And so you had to go 24 divided by 6 is 4. That part's done. Multiply by the 2, that's 8. And so that's what I want to do is on our list, I'm going to put multiply and divide. But if they're back to back, you go left to right. So in our case, the problem I showed you, the division happened to be first. And so I did the division first and then the multiply second. So what's left? What's left is step number 4. And step number 4
Subtraction.
is add and subtract. Guess what? Step number 4 is add and subtract. And we ran into the very same problem with this first one. I kind of wrote these small and kind of tempted you to add that first. The truth of the matter is subtracting and adding are equal. And so when they're back to back, you know, one right after the other, you have to go left to right. So 10 take away 5 is 5. 5 and the 2 more is 7. This is the correct answer. Can you see? We can't have everybody coming up with a different answer for each problem. We'll never get anywhere until we get everybody organized doing the exact same thing. And how does that work? Well, in this case, it would be left to right again. So let's see if it's gonna pop up. Yeah. What do you think? So have you seen this before? This list?
Please excuse my good Aunt Sally.
Yep.
Yeah, okay, let me go back and I want to fix my notes. Yeah, there it is. So it's left to right on this. So people memorize this two different ways that I know of. One was PEMDAS. Parentheses, exponents, multiply, divide, add, subtract. That was one way they memorized it. Now, if you never memorized it, that doesn't sound familiar. But the problem with this is that the multiply and divide are equal. That's why I like my list better. And add and subtract are equal. And so this seems to look like multiply beats division and adding beats subtraction, but it's not the case. Okay. And then the other one, they used to teach it, please excuse my dear Aunt Sally. That was another way to memorize it. It's a silly thing, but people remember silly things. And so, but again, the multiply and divide, you've got to keep this in mind, that this is the true list. Okay. So if that's the case, let's go over the symbols that have to do with, let me see. Okay. All right, got it. Okay, so here's what I want to do. I want to just review these really fast. When you need to add, you may use this symbol like that. You may use the word sum. Remember that we talked about it last class. And so, you know, there's a few other ways to do it, but these are the ones we've focused on so far. When you say subtract, the symbol is typically the minus sign. And does anybody recall the word? The word number?
Difference?
Difference. Yeah, find the difference. Diff ER. Have to play games with this. I had trouble spelling ERENC, difference, okay? And then multiply. There were symbols for multiply. The X, the dot, the parentheses, right? These were all multiplication symbols. And does anybody remember the word?
Quotient, something like that. Quotient.
That's for divide, but I'm glad you're remembering these.
Product?
Product was the word. So that was product. And then finally, with division, it was quotient. So I just wanted, I'm not crazy about vocabulary words, but they're going to use these words so often, product and quotient. They're going to use them so much that you really want to make sure that, you know, they start to click. And so let's look at some of the problems they actually have us do. So this is 1.7. So we've got a list. We definitely have a list of what needs to be done first. So let's see what kind of trouble we can get into. Okay. All right.
We don't want no trouble.
You're not going to get into any trouble? Okay. 20 divided by 2 times 10. Now, if you remember my list, the two operations are division, this is division symbol, and multiplication. And if you recall, they were both equal at the same level of importance. Therefore, the rule left to right takes in place. So can anybody tell me the correct answer to this?
100.
Yeah, 100. So you would do this first. 20 divided by 2 is 10. That part's done. Then you multiply by the 10 at the end. That would be 100. Okay, this is a plus. So what gets done first?
Left to right, the multiplication.
4 times 5.
And notice this is adding, which is lower priority. So I would do the multiply first. So I would put these two together and call it 20. What do I do next?
9.
9
can-
times 7.
9 times 7,
How much?
63.
8.
Correct. Now, notice how we keep going down. This is the safest way to do it, is keep going down so that you can look back real carefully at what you've done. Now what?
Add.
Add. How much?
83.
Okay,
83.
83 looks good to me. Get rid of that. 4 times 3 plus 2 parentheses 5 minus 3. What is the winner?
Parentheses,
Yay.
you get that
Oh.
2.
So this 5 take away 3. See, subtraction would be dead last normally.
Mhm.
Because it's in parentheses, it becomes first. So 5 take away 3 is 2. And I'm going to keep that in the parentheses so I can see that that turned into that. I'm going to put the 2 out here. I'm going to copy the rest of this mess.
So, just like a clarifying, if for say on the original problem, the 4 times 3 was also in parentheses, would you do the 4 times 3 first? Or would it just matter which direction you go?
It actually wouldn't matter because they would both be winners. So if, in fact, if
Oh,
it's
right, it's the
parentheses
same like,
here, it wouldn't have mattered. Then they would have been unnecessary, to be honest. This was,
Okay.
these parentheses were necessary to force you to do that first. Now, notice adding is dead last. So the next level of priority would be the multiply. So how much is that?
12.
12.
12.
And now notice, I just copied the parentheses so I could see this, what was going on. But this is another symbol to say multiply. So 2 times 2,
4.
4.
and then finish it.
16.
Yeah, how is that?
Good.
Let me do one with an exponent. Parentheses, 10 squared plus 100 divided by 4. We have a little static here. I think it's like turn off the mic. Okay. So according to this, these parentheses are only being used to say that this thing is multiplied to the 4.
Mhm.
Nevertheless, parentheses or the exponent takes the cake here. That's the top one. So what do I do first?
And that's your 100.
10 squared.
10 squared, or 10 times 10. 10 times 10?
100.
100. So I'm going to copy the parentheses so that it's in signaling I'm going to multiply by the 4. And it's kind of up to you how many things you do in one step. But this adding is last. So what's next?
Parentheses.
4 times
The
10.
thing about the parentheses this time is there's absolutely nothing to do inside them. So when we say parentheses, we mean there was something to do. Remember how there was one case where we had to subtract? But these parentheses are being used to just multiply.
Mhm.
So we can't do anything about this number here, but admire there's a number 100 in there. Could somebody turn off their mic? Yeah. So 4 times 100, I mean, 400, yeah. And then this, that was multiply, which is, and this is divide. This would be next, wouldn't it? So 20 divided by 4,
5.
yeah. You see? And then notice how that adding is the very end, the very end. But we keep writing down, and we'll do this in this course and in algebra, we keep writing down so that we have a really good shot at seeing what happened. And if there's a mistake, we can see it. What do you think? Do you think this is going to work?
Yes.
I want to do one with a fraction line. Let's see. Now, the fraction line forces you to figure out that the top part of it, which is called the numerator, who cares, and the bottom part first. Even though like subtraction is typically last, you've got to make this top into a single number and this bottom into a single number before you can go forward. So let's work on the top, called the numerator. What would you do first for this?
You would do 6 times 2.
Correct. So that would be 20 plus
12.
12, okay?
And then you add that
And so in the end, you would add it, and that would be what, 32?
32.
But the bottom, the 11 take away 7, that has to be done to make this into a single number. So what is that number?
4.
4. So what I want you to do is see that I took this top number and condensed it to a single number. I took the bottom and I made it a single number. Now I can do the division. So this may seem out of not obeying the rules, but it's part of parentheses where this is grouped and so is that. So 32 divided by 4, answer then
8.
8. So you want to obey these rules like nothing else. You know what I'm saying? You've got to pay attention. And so I want, as far as parentheses concerned, there's 3 shapes. This one, and there's actually a third one, which looks like that. These are all under the parentheses rules. And so the only reason they change the shape at times is because you want to see which one goes with which. And so the 2 can be matched up. Let me see if I can find a different one. I think. Okay.
Can there ever be parentheses like right next to each other without like a multiplication sign in between or division sign in between? Like,
Well, I don't know if you're asking this question like that.
yes.
Yes, so in this case, the parentheses are used to show multiply. Because if you just write 3, 5, somebody's gonna think that's a 35.
Could it be like a 3 times 5 inside and then
Yeah, and so this is basically you 3 times 5. You could have that same problem like this and you would still, it would still say 3 times 5.
it's a division in one parenthesis?
And that's, yeah,
multiplication
so you could
in the
have one or both, but you can't just leave it plain because then somebody's gonna look at it and say 35, and that's not what you wanted. So when you wanna say multiply and you're talking two numbers, you've gotta either use the parentheses or use that raised dot, something like that, to show, and we'll try to avoid the little x for multiply because of the confusion with algebra. But the parentheses is used and the raised dot is used quite a bit. Okay. There are a few problems that have to do with word problems, and I want to go over a few of these. Twice the sum of 10 and 3. Now, this is where you're going to have to remember this because sum implied addition. But there's two things going on. You've got to do twice something. And so there's a few problems in 1.7 that will ask you to do this. And so what they're trying to do is, this is English, and we want to turn it into math. So we're translating from an English expression to a math expression. Math is also a language. And when I was in school, and many of the students were from somewhere else, and I was at the University of Massachusetts, most of the students came in from a different country. We could all understand the math once we got it out of English. Everybody could follow it perfectly without the language. And so our problem is to get this out of English into math so that we're all good. The trick with these is the very first thing that's mentioned has to be taken into account. This is twice, which is 2 times. 2 times something. 2 times what? Well, that's what it's about. The sum of 10 and 3. Now that's 10 plus 3. The sum is adding 10 plus 3 would be 10 plus 3. But how do we make this look right? We want it to be twice this. And so the only way that can work is putting the twice, the 2 times at the very beginning with the parentheses. Okay? They didn't want you to solve this. They wanted you to translate it into the correct expression. So this is the answer they wanted. Let me do some more because this is not completely obvious. Nine subtracted from X. Let's do that one first. This is review. I don't know if you recall this, but if you had notes, subtracted from, what does that mean as far as it's a subtract problem, but which it comes first, which comes second?
The X would,
That's right. The X comes first and the 9 comes second. I'm going to have to reboot this. Let me just quickly get it back. So subtracted from, that was the one, that was the exception where the order switched. So I have a problem and a variation of this. 9 subtracted from product of 3 and 5. Okay. Reboot this. Nine subtracted from the product of 3 and 5. So what you say first is you've got to subtract 9 from something. The product of 3 and 5. How do I write that?
3 times 5.
3 times 5. And so I could use the dot. 3 times 5. Now, how do I do 9 subtracted from that?
You put the 3 times 5 in parentheses.
minus 9.
You know.
Yeah. So so it's 3 times 5 minus 9. I'm going to wait a minute and see if it's going to pop up. There it is. So the parentheses could have been put around the 3 times 5, but if you look at it very carefully, the multiplication would have had to be done first because subtraction would be dead last. And so, you know, somebody was suggesting putting parentheses around the 3 times 5. That wouldn't hurt. It's not necessary, but there it is. Okay. So when you look at these problems like this, be sure. And the very first thing they mentioned, that's what you've got to take seriously. Okay. So you may have questions when you get to that, but let's look. What I'd like to do, we have a few minutes. I want to do, although it's not due on Wednesday, I want to start looking at fractions because fractions take us a little time. And so here's what I'm going to do. So here's 2.1. And we're going to talk about multiplication and division. And the very first thing I'm going to do, I want to talk about what you can do with fractions. Now, I have a fraction 1/2, and most people have a clear picture. They draw all kinds of circles and they have half of the circle, that kind of thing. So hopefully 1/2 makes sense. It's 1 divided by 2 is the other way to look at it. There are equivalent fractions. So I'm going to have a fraction over here, 5 divided by 10. Are these two equivalent? I didn't say equal.
Yes.
They are. And
Yeah.
so many times we prefer this 1/2. Other times we'll prefer this, something higher, but still equivalent. And so we need to be able to get from one to the other nicely. And so one way to do that is this. I'm going to multiply by 5 divided by 5. Now, just look at this right now. How much is that worth? 5 divided by 5. What's the simple version of 5 divided by 5?
1.
1.
So what happens when I take 1/2 and multiply by 1? Shouldn't I get what's equivalent? In other words, multiplying by 1 should not change it, should it?
That's right. Yeah.
And that's what I wanted you to see. So now I'm going to multiply 1 times 5. I'm going to put the answer here. And 2 times 5 is 10.
Mhm.
So in order to get from one fraction to its equivalent, you multiply by 1. And so I'm literally going to be writing those in. We're going to multiply by 1. Now, at the very same time, if I had a fraction like 9 divided by 12, sometimes I want the simplified version of this. And so what I'm going to do, there's two ways to do it. One way is to say, well, darn, I think I can see 9 is 3 times 3. And I think I can see that 12 is 3 times 4. That's a really good clue. So if one way to do it is 9 divided by 3, 12 divided by 3. So I'm dividing by 3 over 3. 9 divided by 3 is 3. 12 divided by 3 is 4. So 9 over 12, by doing something responsible and reasonable, ends up with an equivalent fraction. And we, many times in your answers, they say, give the simplified answer, reduce it. And so we have to be able to do that. Now, sometimes people have trouble with this. And so what I'm going to do is suggest something else. This 9 is actually 3 times 3. And this 12 is actually 3 times 4. And so if you write it like this, you can double check, did I write the right answer? Yes, I did. But then this 3 divided by 3 is 1. And so I can cancel. So in some cases, I brought that fraction in that I needed to make it larger. In this case, I'm taking that fraction out. 3 divided by 3 is 1. This reduces down to 3/4. So what you may or may not be thinking about, which we kind of need to do, is to stop thinking of 9 as 9. Forget 9. Think of how it's made. 9 is made by 3 by 3. And 12, one way to get 12 is 3 by 4. This makes the product of 12. These two numbers are the factors. And so then when we break it down like this, we can see better what needs to happen. Okay? So they do a lot of problems with fractions, but let's see. All right. Six divided by 8. You've done this before, right? How's our time? Good. In this case, the instruction would be to reduce it. Can you think of what they have in common? In other words, instead of thinking in number 6, you're thinking of what two numbers multiplied to get 6.
2.
Yeah, 2 times 3, right? In other words,
Mhm.
looking at looking at what makes up the number. And then 8, can somebody think of some way to get 8?
2 times 4.
Is this working?
Yes.
And so once you get it like this will be something that'll be handy. The 2 divided by 2 cancel down to 1. We're left with 1 times 3 is 3. 1 times 4 is 4. Okay. Now I want to do this. What about when the top number, the numerator, is larger than the bottom number?
We have to find the common number that they both fit into. So this case would be
Well,
30.
I picked numbers that wouldn't break down any further. So what we want to do here, this is a different story, but this is definitely something we'll see, where this number is larger than this number. We're going to make a mixed number. Anybody know how to do this? 7 divided by 5.
Yeah, 7 divided by 5 is 1.
It goes 1. How many left over?
2.
2.
2 out of
Oh, 5.
5. So the way this is done, 7 divided by 5. And so it's almost like you're doing this, like that division. 5 into 7 is 1. How many left over? 2 over 5. And so instead of saying remainder, we're actually going to write it as a fraction. 1 2/5. Have you done this before? Let me do another one. This is 33 divided by 27. So now if you need to do it, you know, on the side, like here, I'm going to write it here. 27 would go into 33 once. 1 times 27 is 27. When you subtract, how much is left over? Take away 7.
6.
6.
6.
So the answer would be 1, and instead of saying remainder 6, we're going to say 6 over the divisor 27. Now, somebody might say, we did a fine job on that. We divided correctly. We got this done. Everything's good. Well, not quite. Because the 6 and the 27 could be simplified a bit. So let's just think about that. We'll put our answer over here when we do it. But 6 over 27. How do you get 6? What times what? So I want you to start be thinking about what makes up these numbers, and we'll eventually do this in a proper way, but
2 times 3.
2 times 3. Now, there isn't a 2 in 27 because this number is odd. And so if it's odd, there's no 2's in there, but there's definitely a 3. 3 times what is 27?
9.
9.
Okay. So see, this is this breaking down. I call it the skeleton view of the numbers. We're trying to see what they came from. Now, what happens here is I've got a 3 here and a 3 here. 3 on top, 3 on bottom. 3 divided by 3. And so I can actually cancel them down to 1. And when I do that, I took out what's unnecessary. 2 times 1 is 2. 1 times 9 is 9. So 6 over 27 turned into 2 over 9. So the very best answer for this would be a 1 and 2 9s. So when you kind of put a final answer, many times they'll say, okay, in this case, they might have give you the mixed number. This is a mixed number. It's a whole number and a fraction. But then they say, well, wait a minute. Not only do we want that, but we want it simplified, which means it's like a clue to say everything has to be reduced. So this here then would be the final answer.
Professor,
Yes, go ahead.
that explains a lot. So my question is, that explains why I always got that answer wrong.
Okay.
But my question is, when we cross out the 3, the common numbers, whatever the common numbers are,
Yeah.
is that in some kind of a way related to something called common factors? Or is that just a totally different
Common
thing?
denominator. This is all going to go together, but we're not there.
Okay,
yet. But
all right, okay.
we're trying to break this down so we can see when you write it like this, you can see what you're doing.
Mm-hmm.
You can check that well, 6 is 2 times 3, it's not 2 times 4. And so then you can see what you're doing. Everybody can see what you're doing. And then it becomes obvious, what needs to happen. Let's try this one. Let me just make up one. 34 over 40. Okay. As a certain point, I made this one up, so it may not be beautiful, but at a certain point, the problems get harder. And so the first thing I see when I look at this problem is this one's even, 34, which means it has a factor of 2 in it. And this is why I made this problem. And this one's even because it has a factor of 2 in it. In other words, if the last digit is 0, 2, 4, 6, 8, it's even, which means it has a factor of 2 in it. So 34, I'm saying it's even, and that means you can divide it by 2. So I'm doing this step on the side. You can maybe do it in your head. It's up to you. But 2 into 3 goes once. 1 times 2 is 2. 1 left over, bring the 14 down. 2 into 14 goes
7.
7. Okay, so a couple people left. The class is not quite over. So 2 times 17. That's 34, isn't it? What about 42? It's even? Can I divide by 2?
Yes.
This one I can do pretty easily. 2 into 4 goes
2,
2, and 2 goes into 2,
1.
1. So I'm just going to make a short version of that.
But then you can't do it again because 17 is not even, but 42 or
That's
20
right. You see,
yeah.
we're getting into the skeleton view. I swear, when you were learning this, let's say there was a class of 30 people. Some people saw into the numbers and they automatically got them right. Others didn't see into the numbers. They couldn't see what was happening. And so they got it wrong. What we want to do is see what's going on. That's what we're interested in, so that we don't make mistakes. This one here, the 2s are going to hit the dust. You ready for that? Right? Because 2 divided by 2 is 1. And so all you have to do is, this is 17, and this is 1 times 21 is 21. And there you go. That's what we're interested. You see how how I did this? So you may have learned it another way. And if you can get this right and do it your way, I'm not going to argue. The only time I want to argue is if you're doing a step that only works part of the time. And so I don't want you to think just because it works part of the time, let's just go with it and hope for the best. Nope, I want you to use a method that works all of the time, 100%. And so that's what I'm interested in. Is that okay with you? I don't want to argue with you. If you've got a magic method, go for it. But I doubt it. Let's see about
Can
this.
it ever be like a number of 0.5 over like the
Oh,
answer?
now you're into decimals. What did you say?
Could it ever be like the answer could be like, instead of the final answer being 17?
Make up a problem. Just tell me what the problem you had in mind.
So I'm like, can the final answer be like a 8.7 over?
Oh, you're thinking about decimals, and we haven't gotten there, but we will.
No,
In the
no.
next chapter, we will get to decimals. After chapter 2, we'll get to decimals. So for the moment, we're going to be dealing with whole numbers. Let's see if I can find something that's half decent. Oh. I want to give you a clue and then we'll stop. remember how we just did a problem that divided by 2? And I knew for a fact that it divided by 2 because they were both even. That's even, and that's even. So I knew that 2 would go in. This may look like a problem that nothing divides it, but guess what? There's a very, very good clue about 3s. And this is how it works. If you add the digits, 3 and 9 is 12. Does 3 divide 12?
Yes.
Yeah. This is the 51. This is one of my favorite numbers because it's nobody figures this out. 5 and 1 is 6.
Mm-hmm.
Does 3 divide 6?
Yes.
That means that both of these divide by 3. And so you can clearly see if a number divides by 3 by adding the digits. So 3 into 39, I think
13.
13. So I'm going to do it like this, 3 times 13. But 51 is the one you may have missed. But like I said, it's my favorite because I like it. Because it hides. You have to know the trick. 3 into 5 goes once. 1 times 3 is 3.
20.
21. 3 into 21.
7.
Okay. So 51 is actually 3 times 17. You see this? I'm setting you up to have good success on this. Now what? The 3s go. That right?
Yes.
And what's left is 13 over 17. And I like to circle them when it's a heck of a mess. So this is it. That's what I'm giving for an answer. What do you think? So the section that has to do 2.1, our time's up, but 2.1 is not due till Friday. But you can see both of these things are super important, that you ace this, you learn this perfectly so that you're never missing an order of operation. And then the whole idea of fractions, taking a larger numbers and reducing it down, or eventually will be taking smaller numbers and building them up. That's how we're going to beat fractions. What do you say?
Interesting.
Yeah. Any questions before we leave?
Nope.
Oh,
I
I-
just
I'm gonna turn the recording off and then